λάβει στην παρουσίαση του επόμενου ομιλητή. Ξεφύγαμε λίγο στο χρόνο αυτό, αλλά νομίζω ότι άξιζε τον κόπο.
Καλησπέρα και από μένα. Για όσοι δεν με ξέρουν, είμαι ο Μιχάλης Κονημάκος. Μαζί με τον Αντρέα, τον Κώστα και τον Μιχάλη κάνουμε την προσπάθεια με το vGRNOG. Προφανώς η συμμετοχή δικιά σας είναι αυτή η οποία δίνει την αξία στην ομάδα. Οπότε θα σας ενθαρρύνουμε και να συμμετέχετε στις εκδηλώσεις, αλλά και να μας στέλνετε θέματα τα οποία σας ενδιαφέρουν, είτε να ακουστούν, να παρουσιαστούν μέσα από κάποιον ομιλητή που θα ψάξουμε να βρούμε ή ακόμα καλύτερα να τα παρουσιάσετε εσείς ίδιοι. Οπότε λοιπόν συνεχίζουμε το πρόγραμμά μας κάνοντας μια αντιστροφή με την παρουσίαση του Κάσπαρ. Είναι συνέχεια ο Γιάννης ο Νικολόπουλος, ιδρυτικό μέλος της ομάδας και με χρόνια συνεισφορά και τον ευχαριστούμε, ο οποίος θα μας μιλήσει για μια υλοποίηση δοκιμαστική ή και παραπάνω, θα μας τα πει αυτός, σχετικά με telemetry που έχουν δει μαζί με τους συναδέλφους του ΝΟΤΕ. Γιάννη, έχεις το πόντιο και με χαρά.
Καλησπέρα. Καλησπέρα σε όλους λοιπόν. Επειδή όλη τη μέρα έχω σοβαρά προβλήματα με την σύνδεσή μου, πρώτα απ' όλα με ακούτε?
Ναι, Γιάννη, μια χαρά σ' ακούμε.
Ωραία. Με βλέπετε κιόλας?
Βεβαίως.
Θαυμάσια. Καλησπέρα λοιπόν και από μένα. Δώστε μου ένα λεπτό. Φαίνεται η οθόνη μου? Θα ρωτάω ένα-ένα.
Ναι, Γιάννη, μπορείς να μοιράσεις την παρουσίαση. Μια χαρά.
Ωραία, έχω μια απορία τώρα, την οποία δεν ξέρω αν πρέπει να τη μοιραστώ με όλο το vGRNOG ή όχι, αλλά δεν είμαι σίγουρος αν πρέπει να κάνω την παρουσίαση μου στα ελληνικά ή στα αγγλικά, οπότε επειδή δεν έλαβα κάποια πολύ σαφή απάντηση, ξαναρωτάω.
Εγώ θα σου απαντήσω αυτό που λέμε πάντα, ότι η ομάδα είναι vGRNOG, οπότε πρώτη μας τέτοια είναι τα ελληνικά σε κάθε περίπτωση και αυτό ενθαρρύνουμε. Εν τούτης, ανά στιγμές, όπως και η σημερινή συνάντηση, υπάρχουν μέλη ή κάποιοι οποίοι παρακολουθούν που δεν γνωρίζουν ελληνικά, οπότε το αφήνουμε σε εσένα, στην διακριτική σου ευχέρεια. Αν είσαι comfortable και ξέρεις, είναι εύκολο για σένα να την κάνεις αγγλικά, ό,τι εσύ επιθυμείς.
Εύκολο είναι για μένα. Τις περισσότερες στιγμές στα αγγλικά τις κάνω. Απλά για το ακροατήριο προσπαθώ να σκεφτώ. Τέλος πάντων, okay.
Υπάρχουν κάποιοι λίγοι οι οποίοι δεν καταλαβαίνουν ελληνικά. Οπότε, αν θες να συμπεριλάβεις σε αυτούς την παρουσίαση, ενώ ώστε να παρακολουθείς την παρουσίαση και όχι μόνο τα slides, τότε θα είδα τα αγγλικά. Ό,τι εσύ θέλεις. Το αφήνουμε πραγματικά σε.
Αγγλικά, Γιάννη, αγγλικά. Αν σου είναι εξίσου εύκολο, αγγλικά.
All right, so hello, good afternoon to everyone. I'm switching to English. Okay, this is going to be a less interesting presentation than the previous one. Actually, I thought that the previous presentations was very, very interesting as well, even though I didn't have any questions. So I'm going to present an introduction to our telemetry deployment in OTE. And I really need to stress that this is an introductory presentation, and people that, and hopefully people can find some interesting stuff and look into this a little bit more as we did. So for people with no knowledge of the model-driven telemetry, it's just when routers can and do stream out very large amounts of data, operational or otherwise, in an efficient and, most importantly, easily consumable way, which is all about today, I think. So what is the current model and what are the shortcomings of the current model? The current model in network monitoring is usually SNMP, or at least in most cases, which is a pool-based model in order to gather all operational stats. And many issues arise. For example, you have scaling issues from protocols such as syslog or SNMP. You have CPU load issues from protocols such as syslog and mainly SNMP. You have a very complex structure. I mean, people who have looked into the syntax of the SMI, the SNMP syntax, know what I'm talking about. So in a few words, it's not very efficient for 2021. What about telemetry? What about streaming telemetry then? Data is streamed from the network. And when we say the network, we're not just talking about routers. We're talking generally about network elements. So we do get a near real-time monitoring, and where we can get as much data off the box as quickly as possible. And in our case, since we're using mostly using Cisco in our network, well, Cisco's model-driven telemetry utilizes YANG models, which is a good thing because YANG is pretty widespread, it's pretty well standardized, and we consider this to be an advantage. So what were the new monitoring requirements? As I said before, we needed high resolution data, even down to a few seconds resolution, even down to 1 second resolution. And another requirement is, we need to be able to analyze and store large, very, very large amounts of data. Dial-out model, which is friendly to the resources of the box that is producing the statistics, no polling required. And then we have many consuming needs nowadays. Data can be graphed, data can be forwarded to other analyzers, data can be forwarded to long-term storage for big data analysis, and so on and so forth. Also, in our case, and I guess in many cases of ISPs like ourselves, we wanted to start using automation based on event prediction. So this is a big thing. I mean, I know it's been hyped a lot, but we've already started using this a little bit. Like, for example, we can monitor the allocation in our IP address pools and provision automatically new pools when needed. A little bit of history. We started our trials a few years ago. I think it was maybe 3 or 4 years ago. We built a test lab. Well, actually, we didn't build anything. We had an ASR 9010, and the configuration was pretty straightforward. A couple of slides at the end contain the all configuration needed. So we started streaming statistics for interfaces like speed, etc., CPU and memory statistics, and some quality of service as well. We used a software called Pipeline to collect. Pipeline was, is developed by Cisco and then open sourced. But even though it's good at what it doesn't do many things, and it actually doesn't scale very well, as we found out the hard way. Configuration in Pipeline is done by means of a JSON file. It's actually a bit of a pain. It's quite complicated to do it by hand, and that's how we did it. I mean, we had to download all the relevant YANG models and find the branches that were interesting for us, and then just put in the JSON configuration file. we used Influx for our time series database just because it was there and it was pretty straightforward to use, and Grafana, which is also pretty standard, as our front end. That's a very basic diagram of the test lab. You have the router at the bottom of the screen, which streams some data to pipeline, and pipeline actually Influx consumes this data, and Grafana produces nice graphs. So that was the proof of concept, and then we moved on. Well, actually, I think maybe 1 or 1.5 years passed till we moved on to the actual first phase of implementation, where we deployed multiple pipeline instances, because as I said before, pipeline does not scale very well. We used pipelines both as producer and consumer, with Kafka bus in the middle. The whole stack was deployed as Docker containers via Docker Compose on a physical machine, on one physical server. We had another one just for redundancy, but we never actually used it. A good thing was that the JSON configuration file was produced from was almost automatically produced from a very nice Cisco tool, and as I said, the whole architecture was a bit complex and not so scalable, mainly because of the pipeline. Another issue we had is, forgot to mention that we swapped Prometheus, I mean Influx for Prometheus, and there we had a high availability issue because we were not aware of simple way to deploy a highly available setup with Prometheus. It doesn't provide it out of the box, I think, and we were left with quite a few questions like what are we going to do about storing all this data? How are we going to aggregate it? How are we going to consolidate it? I mean, even though we only had a few routers, like 20, 30 routers, the amount of data was already getting out of hand. It was a lot of data. So this is what it looks like in a very simplified diagram. Again, we have the network elements on the left side, the left-hand side of the picture. We have the pipeline producers on the left-hand side and the Kafka bus in the middle. The pipeline consumers on the other end, on the right hand, and data being fed to Prometheus, and Grafana dashboards produced from the data that were stored in Prometheus. And as I said, all those were inside one physical box and deployed as containers. I must stress out at this point that most of the work, at least the deployment phase, was performed by our Cisco colleagues, which I'm going to mention a bit later on as well. So that's where we stand right now. Actually, right now we've already started deploying the second phase of this stack. Pipeline is already being replaced by Telegraph, which is a vast improvement, because now the solution scales much nicer. Prometheus is being complemented by InfluxDB. I mean, the thing with Influx is that it does support clustering, although you have to pay for it. So right now we're still thinking how we're going to fit both Prometheus and Influx in the same picture. We're also considering capacitor and chronograph. So we're going to have a full-blown tick stack. for alerting, querying, etc. And again, we still have the same questions as before about what we're going to do with storing all that data and consolidating. We're considering our options. There's quite a few options. One possibility is to use Prometheus for the high resolution data and then forward the data to Influx to keep a lower resolution but longer periods of data, so we can go back to even years of data. So as I said, it is a tick stack with the addition of Prometheus. We've also probably got rid of Kafka as well. And for now, this stack is deployed again as Docker containers via Compose, but soon it will be replaced by containers, probably Docker, but not sure, not 100% sure on that. We're still thinking about it. On Kubernetes over OpenStack, which to some might sound a bit of an overkill, but we do have some experience in deploying such clusters in a redundant fashion, so we're quite comfortable and confident with that. So this is what the new stack looks like, or will look like. Again, we have the network elements on the left, and then telemetry is being sent to Telegraph, and then InfluxDB and maybe Prometheus before InfluxDB, as I said, chronograph, and finally we have some nice dashboards in Grafana. So I have some useful references if you want to check out. Also some acknowledgements. You have Theodore Kyriakidis and Takis Amanis from Cisco that did a lot of work on this, actually most of the work. Nia Provia, Dimitris Stamatiadis and Marinos Ondrogianoglou from OT that did quite a bit of work as well. And if I still have a few minutes, I can show you. I can just show you what we've built from the telemetry data. Right? Can you see my browser? I hope you can.
Yes, Yannis.
Okay. So, for example, here we have all the network elements currently being monitored by currently producing telemetry, all their interfaces, etc. So we monitor the CPUs and then inbound and outbound traffic for all interfaces. We also monitor drops and some errors. That's just your basic, very, very basic monitoring stuff that we used to do with SNMP as well. Another use case we have is we use telemetry data to monitor our DDoS mitigation. We're using NetScout, formerly known as Arbor, TMSs for that. So in this graph, you can see the off-ramp and on-ramp attack traffic. This also comes from the streaming telemetry. For example, you can see here on the top graph that we had a 5 gigabit attack on yesterday around midnight, and we can tell from the bottom graph, the on-ramp traffic, that the attack was handled very well, and only 30 megabits of that passed through. Another test case we have is the one I mentioned in the beginning, the IP address utilization, the IP address pool utilization on our BNGs. For example, here we can just view the address pool utilization in a specific BNG. You can see that it's currently sitting nicely at 70%, so no action is required. And the action part, we have two options here. I mean, either use Python or Ansible, or use NSO, which is another automation framework that we also own, and it's well, it's Cisco's. It used to be developed by TLF, but now it's Cisco's. And final use case, I mean, we use telemetry data to monitor our MAPI deployment. Yes, we have a MAPI deployment. When it when it picks up more than 2,000 users, well, we can have another presentation for that, I guess. So now here we can see the actual traffic from our MAP subscribers. This is taken on the BR, meaning we see only the IPv4 traffic of our subscribers. On the top graph is the total inbound and outbound traffic from all BRs, and the second graph is just the inbound traffic per interface, and the outgoing traffic again per interface. The last graph is the number of MAP users, but this is totally unrelated to telemetry. So yeah, that's all I had to say. Thank you very much for bearing with me, and if there are questions, I'll be happy to answer.
Γιάννη, ευχαριστούμε πολύ για την παρουσίαση. We will be taking some questions. First of all, thank you, John, and we will pass the mic to Paolo Lucente. I'm quite sure that he's quite aware of the topic.
You should have told me that, Paolo, was in the presentation.
Okay, hi, Paolo. The mic is yours.
Hi, Michalis. Hi, Yannis. Fantastic presentation. Thank you very much. I had two questions. So the first is whether you are like a single vendor kind of shop, or whether you also had the problem of normalizing data among different vendors. Like, for example, you have Cisco and Juniper, and now you get the interface counters, but these two platforms are sending, maybe they even support different models, right? So did you have that normalization problem? And if yes, how did you solve it? And then the second question was like, I saw the demo that, you have interface counters there along with some other simple models like the CPU counters and things like that. However, when I try to play a little bit with streaming telemetry, for example, going to quality of service, so like counters per queue per interface, my recollection is that it was a little bit broken, right? So there are basic models working, but a little bit more hierarchical models, maybe things are still broken when it comes to streaming telemetry. And so whether you had that experience, and what is in general your take about models quality and things like that?
Okay, first question. We're too early in the development. I just realized, I mean, your question made me realize how early we are in the deployment, because not only we don't have we haven't reached the stage where we stream telemetry from other vendors' machine. We haven't even touched all Cisco's operating systems. So for now, we're just streaming telemetry from Cisco IOS XR machines. then we're going to go to IOXE, and then we're going to go to Juniper. Actually, no, not Juniper. Sorry, I mean Nokia, Alcatel Nokia. So no, we haven't yet. And as for the second question, you're right. I should have shown you. We also we've done quite a bit of work on the quality of service models as well. And as far as I know, there were no issues. I'm quite confident that it was much better than the ones that we had using SNMP, because I remember, because it had taken me many hours to try and correlate different OIDs from different MIBs in order to produce meaningful graphs. So in a few words, I think QoS is working fine.
Thank you.
Okay, thank you, Paolo. We have another question from Kostas, and if we have time, I just want to do a brief comment.
Hello, Yannis. Although speaking after Paolo, who has the real expertise on the subject, is a bit difficult, but I wanted to ask a couple of simple questions. One is the collection currently for any data that you receive. You mentioned that they are, of course, modeled after Yang, but are they encapsulated in protobufs, in Google protobufs?
Yes.
It's like that, huh? Okay.
Yes.
So this was the first, and the other was, in terms, I guess that the major problem that you will face is the scalability of the database and the backend, and whether you will be able to produce useful reports out of it. Paolo would definitely be the person here to provide input, but all the architectures that I know of utilize Kafka, a Kafka bus. And from what I saw in your presentation, in your current setup, you have removed Kafka, you mentioned.
Yes.
Okay.
That's correct. Although it's not finalized, but yes, for the time being, we're just considering removing Kafka. Okay. But okay, sorry, go on, finish your question.
Oh, well, the only question is who will actually provide you input about the scalability of the backend? Because it is only rumors from my side. I have heard, for example, that InfluxDB does not scale to large amounts of data, and perhaps it is the same with Prometheus. I personally, by rumor again, I must say, nothing else, I know of 2 databases that can scale for this kind of applications. One is a Druid, Apache Druid, and the other would be ClickHouse. This is just to share information. As I said again, Paolo has the real expertise in this area.
Okay, just to answer both questions a little bit. For the first one, yes, the data has been encoding in Google protobuffers, and for now they just send over TCP. But if I remember correctly, all the 64-bit Cisco boxes also support gRPC, so we're probably going to switch to that once once most of our boxes are 64-bit. And as for the second one, I mean, you're right. We haven't got all the answers for the scalability. It's actually one of the questions we keep posing to ourselves. So when we get to like a later stage, I might just send an update on what we did.
Perfect. Interesting follow-up for the next vGRNOG, perhaps. Thank you.
Okay, one last comment from my side, Yannis. You mentioned at some point in your presentation that you are considering some actions regarding, after parsing, let's say, the data and perform some actions based on that. Have you checked any solutions, or do you have any thoughts about it? I mean,
yeah, well, yeah, I mean, again, we have done very, very basic trials on that, just using simple Python hooks. But as I said, we're considering using the Cisco's NSO framework for automating some actions, you know, in order to somehow implement some sort of closed loop automation or something similar to that.
Okay, fair enough. Okay, so thank you very much for your time and presenting, for taking the time and presenting in vGRNOG12. Hopefully, we will see you soon in person, and we can continue with the rest of the program.
Thank you.